Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on GeeksForGeeks for 1st May 2023. The problem statement for today is subtree in N-ary tree. Let's now open this problem to solve it. So before going to the problem statement, I would just like to explain that the N-ary tree is a tree that allows us to have n number of children of a particular node. Hence, the name is N-ary Tree, making it slightly complex than very common binary tree that allows us to have at most 2 children of a particular node. So in this type of tree, we can have n number of children for a particular node. Okay. Let's now go through the problem statement and understand it clearly. So problem statement says, given the root of N-ary tree, find the number of duplicate subtree in N-ary tree. Two trees are duplicate if they have the same structure with same node value. Okay, so the problem statement is asking us to find the duplicate subtrees. So we are given the root of the N-ary tree and we need to find the number of duplicate subtrees in the tree. Two trees are again considered duplicate if they have same structure and the same value as it is said in the problem statement. So we need to find all the subtrees that have common that have the same structure and node value. Okay, so let's go through the given examples here. So first example says this is the given input, and from this input the tree can be constructed in this way. Okay, so each level, after each level, it is represented by a null here, n which shows that that is the end of that level. So for 1, after that no other elements are there in that node, so n is there. Then 2 to 3, so the children of 1 is 2, 2 and 3. So after that again 1 n is there. So again after that the 4 is there, only one child of 2, again n is there. Then 2 has 3 children, that's why it is 4, 4, 3, and 3 does not have any child, so it is all n after that. Okay, so here it is saying the output is 2. Explanation is that 4 and 3 are the duplicate subtrees. So if you look at this, then 4 and 3, these two are which is the highlighted in black and blue, these two are the duplicate subtrees. That means subtree starting with starting at this root. So here even the root node can be considered as a separate subtree, so that only is considered here. So these two 4 and 3 are the duplicate subtree. That's why the output is 2. When we go to the second example, so second example says this is the given input. So again the tree is constructed in that way only. After 1, this n or null that indicates no other node are there in the same level. After that its children are 2, 3. Then the children of 2 is 4, 5, 6. Then for 3 we do not have any children. So here the output is 0 because you can see no duplicate subtree is found in this one. Okay, so I hope the problem statement and given examples are clear. So to solve this problem, we can use a recursive approach. We will traverse the N-ary tree in a postorder manner, and for each node we will construct a string that represents the subtree rooted at that node. We will also keep track of the frequency of each subtree. Okay, so with this approach, let's try understanding the first example, how it will be executed step by step. So for that we will be moving to this one. See, when I said about that we will be traversing it in post order, that means post order manner, that means the child will be considered first before considering the parent. Okay, so here when we start from this root node, then when we start from the root node, then we go to its left child, and after that recursively we go to the deepest level, and there we get this. At last we get this 4. So for this one, for 4 we do not have any child, there is no children for this node, so that's why the child string, this array is blank here. Then since we are considering this 4 here, then before adding to map, actually we will be creating a hash map to store the frequency of each subtree. So I will just written it that what is the value that is going to be added to the map. Okay, so to construct the subtree string, we can start by appending the value of the node followed by a colon. Then we can append the subtree strings of all the children separated by a comma. We will sort the string of the child before appending them to the parent. Okay, we will sort the subtree string of the children before appending them to the parent string to ensure consistency in the subtree structure. Then we will finally return the subtree strings. Okay, so let's go through and understand that how this approach is being used for creating this map and the subtree strings. Okay, so as I explained there that when we go to this level, so that time we did not have any child, so this is blank here. So 4 is going to be added to the map. So after getting added to this map, we are saying that this subtree which is rooted at 4, the frequency is 1 here. Then after that we move a step backward. Okay, as I again said that before appending that we will be considering the child element before considering the parent. Then this is the post order manner in which we are traversing the entire N-ary tree. So when we go back and when we are 2, so the child of this 2 node is 4. So the child strings is 4. So before adding to this map, so now the subtree is considered is 2 and 4. So before adding to the map, the subtree is 2 and 4. So when this will be added to the map will become 2, 4. This frequency is 1, and for the subtree 4, which we considered earlier, that frequency is 1. So for this particular for this entire tree, here we are getting 2 subtree. One subtree that consists of 2 and 4, other subtree consists of 4. Okay. So now after that we go to the next one. So after again we even for this one, even for this node, this subtree, we go to the deepest level. So again we check, we are at this level 4. So 4, again it is saying that here the comment here is not here. We can write the child strings. So for this 4, the child string, again this does not has any child. This has no child. That's why this array is blank here. Then this will again be going to be added to the map of the frequency map. So 4 is again going. So it sees that 4 is already there in the map with the frequency 1. So it just adds to that and increases the frequency by 1. So after this we can see till now we have got 2 subtree with 2 subtree of 4. That's why the frequency here is 2, and 1 subtree that consists of nodes 2 and 4. So the frequency here is 1. So 2, 4 is 1, and 4 we have got twice. After that again we move to the next node. Again we are getting 4. Again here 4. So again it will go here. It will go to be added to the map. So before adding to the map, here the element which is going to be added is 4. So after adding to the map, it will become the 2, 4 subtree that is still having frequency 1, but for 4 subtree with 4, that is 3 now. 1, 2 and 3. Next one is 3. Again it does not have any child, so this is blank. So now the element or the subtree that is going to be added to the map is 3. So after adding to the map, it will so then the map will look like one substring of 2, 4, 3 substring of 4, and 1 substring of 3. So this is the one. 2, 4, 1, 4, 3 and 3, 1. Next one. So once this is done, then we move to the parent as we did in the previous step. Then after considering 4, we consider 2, 4. So once we considered all these 3, then we move to the subtree that includes their parent, which is 2. So now when we move to this level, so it consists of 3 children, 4, 4 and 3. So that's why this child string will be 4, 4 and 3. So the subtree which is going to be added to the map is 2, 3, 4, 4. 2, 3, 4, 4. Actually we are sorting it in the ascending order. Okay. So after this added to the map, so the map will look like one substring one subtree that consists of 2 and 4, 3 subtree that consists of element 4, one subtree of 3, and one subtree of 2, 4, 4, 3. That means 2, 3, 4, 4. So we can see for 2, 2, 3, 3, 4, for this subtree frequency is 1, for 2, 4 frequency is 1, for subtree 4 frequency is 3, for subtree 3 frequency is 1. Then even this is considered. Now we are moving to 3. So again 3 is not having any child, so child string is blank here. Before adding to map, so the element which is going to be added to the map is 3, and after its addition to the map, earlier we know there was one occurrence of 3, that means one subtree of 3. Here we are again getting another subtree of 3. So what it will do, it will just add the count, frequency count increases by 1. So here we can see after this the map will look like this: one subtree of 2, 3, 4, 4, one subtree of 2, 4, three subtree of 4, and two subtree of element value 3. After that, all these levels are completed. Then what we can do? Then we move to the topmost level here. So we can see again when we are moving to this level, then we consider all the childs. So this will consist of this one. The subtree string will consist of 2, 4, 2, 3, 4, 4, and 3. So that only is here: 2, 4, 2, 3, 4, 4, and 3. Okay. So actually each subtree of a particular node is separated by a comma. That means when we are considering a particular subtree and its child elements, all these are separated by a colon, and all the subtree of a particular node, that is separated by a comma. So if it is in the hierarchy, it is separated by a colon. If it is in the level wise, then it is separated by a comma. So that's why we are getting here 2, 4 as one subtree separated by a colon. After that we have comma here. Then 2, 3, 4, 4. This is another subtree. This is where it was. Yeah, this one. 2, 3, 4, 4. Another subtree. That is again, after that again we have comma. Then 3 another subtree. So all these 3 subtrees are separated by comma. So now this is the complete subtree, which is the child which is the subtree rooted at 1. This is going to be added to the map. Okay. So now this will be added to the map, which consists of 1, 2, 3, 4, 4, then 2, 4, and 3. All these things. This complete tree. So after this addition to the map will look like this one, with 2, 3, 4, 4 frequency is 1, subtree with 2, 4 frequency is 1, subtree with 4 frequency is 3, subtree with 3 frequency is 2, and the topmost level for the entire tree, the frequency is 1, which consists of 1, 2, 3, 1, 2, 3, 4, 4, 2, 4, and 3. This complete subtree string, that frequency is 1. Okay. So after that we see that we have reached the end of this loop. That means the end of the complete tree is traversed. Then it will return from this one. So before return, the map will look like this one. This is again the same thing whatever we have seen in the previous step, this one. So here we can see, now we have to check that how many subtrees are repeating. That means what is that subtree structure that is occurring more than one. So here we can see for subtree that is rooted at 4 and subtree which is rooted at 3, that these two are having count greater than 1. For 4 it is 3 times, there are 1, 2, and 3, and for 3 it is twice, 1, 3. 1 and 2 for these two subtree of 3. So the count here is 2. So that's why the output will be 2, which is saying that 4 is repeated and 3 is repeated. That means 4 and 3 are the duplicate trees. Here one thing to consider, this subtree, that means 2, 4. This is not identical to this one, 2, 4, because the subtree which is rooted at 2 contains element 2, 3, 4, 4. We cannot consider these 2 and 4 as a separate subtree. This is not true. This is not correct. So one subtree is this one. That means all the children of a root rooted at that particular rooted at itself, that is considered one subtree. We cannot leave 4 and 3 and consider 2 and 4 as a subtree. Okay, I hope the explanation for with this example this is clear. So whatever the steps I have explained here, the same thing I'll be using in my answer in the code as well. So just to save in time in typing, I have already prepared the solution. Let me just copy it here. So this will go here. Yeah. Yeah, so here I'll explain what all things I have done here. So again, the logic is completely same which I have explained for this example, nothing else. Okay, so here we are constructing, initializing a map to store the subtree string and its frequency. Okay, then we will traverse the given N-ary tree in post order, which means that we will first visit all the child nodes of a parent node before visiting the parent itself. Then for each node, okay, then here for each node we will do the following steps. Okay, for each node we will construct a subtree string that represents the entire subtree rooted at that node. The subtree string will be constructed as follows. The first, we append this one. For this we are calling this one construct subtree. We are passing that root node and passing the map which we have just initialized in the previous step. So we are passing that to this method. Okay, so first we append the value of the current node to the subtree string, followed by a colon. So whatever the value we are getting, we are adding to this one and we are appending a colon. Next, we construct the subtree string of each child of a current node recursively and append them to the parent subtree string in lexicographically sorted order, separated by a comma. Okay, so whatever the child nodes are there in this one, so that we are again constructing a subtree for each child of the current node recursively and append them to the parent subtree string, and these all things are separated by a comma. So this exactly is meaning the same thing. That means all the nodes, that means all the children node of a particular node and the node itself, those are separated by a colon, and this complete subtree, this is separated by a comma. Okay, as we construct the subtree string, we will maintain a map to store the frequency of each substring we have encountered so far. So here after this appending of comma is done, then we are whatever the map which we have created earlier, so we are storing that frequency of that particular subtree in that map. So here in the key will be that entire subtree, and the frequency it will be if it is already existing, then get that value +1, else get the default value that is 0 and we add +1 to that. So that means if we are encountering a tree which is already existing, in case of 4 was already existing, so initially the count was 1. When we encounter the second one, so we got that particular subtree from the tree map and we incremented the value by 1. So the value became from 1 to 2. But whenever we are getting a new subtree that is not present in the map already, then we are getting the default value which is 0 and incrementing it by 1. So it will just say that the map will just store that substring and that not substring, that subtree string with the frequency count as 1. Okay, once this complete thing is done, then we return the substring. So after constructing of the subtree for all the nodes, we will iterate over the map and count the number of subtree that have encountered more than once. So once we return after this one, then we then here it will return from here. Then we are having one count variable initialized with 0. Then we are iterating through all the nodes of the map. That means we iterate over the map and count the number of subtrees that have occurred more than once. This will give us the number of duplicate subtrees in the N-ary tree. Okay, I hope the explanation is clear. So again, I'll just summarize it once. We are creating a map, then we are calling the construct subtree string. We are getting the node data for a particular node and we are appending a colon for it. Then we are recursively calling this method for all the child nodes, and we keep on adding all the child separated by a colon. So it will be like 2:4. That represents a one subtree. Once this is done for that particular node, then we sort it so that we get it in lexicographic order. Okay. Then after that, once that particular subtree is done, then before moving to the next subtree, we append a comma there. Okay. And once this is done, then we add that particular subtree into the map with the frequency count initially as 1, and if it is already existing, then we are incrementing the count by 1, and after that we return the subtree string. And once after it is returned, then here once we are returning from this one, then this tree map will be updated, because this is initialized before calling this method. So we iterate through that map again, and we count which subtree is having frequency more than 1. So that we will count, that how many subtree is having frequency more than 1, that we will count and just return that, the count of duplicate subtrees. Okay, so this was the coding part of it. Let's try compiling this code. So here we can see we have got correct output for this given input. Okay, let's try with the input which is given in the problem statement. That was a different input. Let me try giving some custom input here. So this should give the answer as 2, because that is the only one which I have explained in this example here, this complete in this output 6 text file. So here see we have got here output as 2. Let's try submitting the solution. So here we can see, here we can see that it is saying that problem solved successfully. Actually, here is something issue with this GeeksForGeeks now. Here it is showing only that test cases of 115 passed out of 2 to 5. I think some printing mistake here, or some numbering mistakes here, but it is showing that it is all the problem is solved successfully, and we have got the complete marks. Okay, so this was the solution in Java. So talking about the time complexity of this solution, it is in the order of big of n log n, where n is the number of trees, n is the number of nodes in the tree. This is because we are traversing the tree in the postorder manner once, and for each node we are sorting the subtree of its children, which takes big O of log n time. So the overall time complexity is big O of n log n. Okay. So if you talk about a space complexity is big O of n, as we are using a map to store the subtree strings and the frequency of the occurrences. So space complexity is big O of n. So this was a Java solution. I have even prepared the same solution in C++ language. Let me just copy that solution here. The logic is completely same. Only the syntactical difference we have between C++ and Java, that is here. Here instead of the class, we are here it has the pointers here. So again we are creating that map here. We are calling this method, and inside that method we are first appending the data of that particular node followed by a colon, and this will happen for all the child of that particular tree, that is called recursively. So this will happen that after that. After we have considered all the subtree, then we are appending them into this string s, and we are separating it by comma. Once that is done, then we are updating the map value by doing ++, and we finally return the string s. After that, in this updated map, we just count that how many subtree has count more than 1. So that count we will return as the final output. Okay, let's try compiling this code in C++. So even with C++ code, we have got correct output. Let's try submitting this solution. So here also you can see we have got the complete score of all these things, and it is saying that it is problem solved successfully. Something wrong with the test cases numbers here, that is there by GeeksForGeeks. So yeah, so this problem has been solved successfully in both C++ and Java language. So that's all in this video. I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.